Merry Christmas, everybody. I hope you're having a great holiday season or otherwise celebrating in a special way the end of the year. Today, we have one more of these Christmas week's episodes. Today, I'll share with you some ideas around how we can enable 24-hour experiments. That means experiments you can think of, deliver to production or an experiment environment in less than 24 hours. And in some cases, even collect enough information to learn within that 24-hour cycle. This is a new topic for me. I've only started talking about this recently, and I've hosted some workshops at clients where, together with the teams, we go through the process of understanding how to run and then actually running 24-hour experiments. In that workshop, it's a 3-day workshop, we actually go from talking about 24-hour experiments in the first day to running 2 24-hour experiments during that workshop. As I record this, I'm not sure yet if this will fit a single episode, but we'll see. We still have tomorrow, the Friday episode, so stay tuned for today as well as tomorrow's episode in this Christmas 2023 bonus week. And don't forget that each of these episodes is a companion to the Coach Your Product Owner e-course, which you can get at bit.ly/coach your PO. All one word, all lowercase. That's bit.ly/coach your PO. All one word, all lowercase. So this week, we cover 5 topics that every Scrum Master should be able to help their POs, product owners, work on. And each of these 5 topics is a complement to one or several other modules of this Coach Your Product Owner e-course. Okay, but let's start with the topic of experimentation. First, we must define experiments. What are they used for in product development? So let's get started. Many of us have learned about lean startup, which is a methodology that is based on the expectation that product development and more broadly, business development, after all, startups are businesses just like any other business. This product development depends on our ability to learn. Lean Startup even coined a specific phrase for that learning cycle. They called it the build, measure, learn cycle. So let's take a quick look at that cycle. Lean Startup defines that the goal of building, in other words, delivering software to production, is to validate some hypothesis and not simply to just deliver software. For us to be able to validate an hypothesis, however, we must have spent some time defining what we are trying to achieve. And for that, check Monday's episode where we talk about how to define value. Once we have a clear idea of what is the goal, we can then set up our hypothesis. And we'll go through an example in today's episode. So let's take Amazon's example. If you haven't heard about it, just check out yesterday's episode where this example is explained in detail. Let's take Amazon's example from yesterday. Say a team at Amazon decided to work on increasing the conversion rate for people that have already added an item to the cart. Somebody in the team would suggest that the shipping costs could be a reason for people not to buy an item. They certainly are for me and for many of you listening, I'm sure. And then the team would set up an hypothesis. And the hypothesis could be set up like that, like this. We believe that, this is the first part, we believe that removing shipping costs from the checkout overview will result in, this is the second part, will result in a higher conversion rate for people who've already added an item to their cart. Now they have their goal. Their goal is higher conversion rate. And they also have their cohort. Their cohort is the group of people that the experiment should run for. And this they defined as people who've added an item to their cart. But the key in this hypothesis is their belief. Removing shipping costs from the checkout overview will result in higher conversion rate. This belief is the key trigger for them to run the experiment. Sometimes we also refer to this belief as an assumption, and ultimately we transform it into an hypothesis, just like I did before. Now, when we put together an assumption and then a metric and a cohort, we are ready to run our experiment. And those are the key aspects here. So belief or assumption, metric, and cohort. Okay, now that we know this, we can run our experiment. But wait a minute, we still don't have the details of an experiment. Teams usually get user stories when they need to deliver software, but what do they get when they need to run an experiment? So now it is time to design the experiment. And how do we do that? Well, first, we must include all the metrics collection in our specification or user stories, right? Since, for example, we want to measure the conversion rate for people who've already added an item to the cart. In this case, we need to be able to create that cohort in our system of metrics and measure the conversion for that cohort, right? And that may have been there already or may not be there, and we need to do the work for it. But there's more. Designing an experiment is a bit like writing a user story, but it's an experiment story. I don't know if story is the right word. I just call it experiment. And I use a specific template for that. And here's the template that I use, continuing the example that we've been talking about, the Amazon example. So first, for any experiment, I define a title. And in this case, the title could be Increase Conversion Rate for People Who've Added an Item to the Cart by Removing Shipping Costs from the Checkout Overview. This title helps us understand what we target, which is increased conversion rate. It helps us understand the cohort, which is people who've added an item to the cart, and it helps us understand the main aspect of the experiment, which is removing shipping costs from the checkout overview. Once the title is clear, we detail the experiment with 4 different clauses. Let's start with the first. The first starts with we do. That's the heading of the clause. And then we just use a bullet point and we list exactly what, or a bullet list, and we list exactly what we will do to set up that experiment. The next heading is we expect. And under this heading, we list, also in a bullet list, exactly what we expect will happen once we run the experiment. The third heading is data we collect. And here we list exactly the data points we will collect. And this is especially important because we must know what data is needed so we can set it up in our metric system. If we don't have the metric, we need to start collecting it. If we do have the metric, but maybe it needs tweaking, then we need to do that tweaking. And this is important because if we don't write the data we collect or the data we need to collect for that experiment, we might end up figuring out later we didn't have the data we needed in order to reach a conclusion. And conclusion is our 4th heading in this experiment template. It's the last clause, and it's about listing the lessons we learn from running the experiment. Of course, we do this only after the experiment is run. When we define the experiment, of course, we don't yet have the conclusion, so we simply list the date at which we will review the results of that experiment and list our lessons learned. Once the experiment template is complete, we will list the main lessons learned in the conclusion clause. So the clauses are we do, we expect, the data we collect, and the conclusion. So let's go back to the example that we were talking about, the Amazon example. And what would an experiment look like for that example? Well, under the we do clause, we could write something like set up a checkout process without shipping costs. And then for the selected cohort, the test group, or 50%, could be any percentage here depending on what you're looking for. But in this case, we'll use 50-50. So the test group, 50% of the cohort will see the total price but no shipping costs, and the control group, the other 50%, will see the total price plus the shipping costs, just as we do so far. We will then measure, this is still under the we do clause, we will then measure the conversion rate for the test and control groups. Under we expect clause, we would write we expect that the test group will see a higher conversion rate. We expect this conversion rate to be 10% higher or more than the control group's conversion rate, and we want to achieve a 90% confidence level on this assessment. This confidence level is important, especially if you're using a numerical experiment or statistics-based experiment. The third heading of our experiment template is the data we collect. And under this, we would write number of people of each of the test and control groups, and also conversion rate for test group and control group. We could add something else like confidence level, etc. here. Up to you how detailed you want to be here, but just make sure that you have the basic data you need in order to make that assessment that we listed in the clause before, the we expect clause. And finally, under the conclusion clause, because we haven't run the experiment yet, we would write something like, we will review the results by the end of the next sprint at the latest. And we could put an actual date there because you know when the next sprint will end. Now, some of you might already be thinking, but Vasco, this experiment might take several days or even weeks to run, depending on how much data you need to reach that 90% confidence. And you'd be absolutely right. That's true. So let's look at what we could do to run a similar experiment in 24 hours or less. So, what we want in the end is to learn faster. But what is it that we must learn? If we go back to the original assumption we designed for this experiment, we see that the core assumption that must be validated was, we believe that removing shipping costs from the checkout overview will result in a higher conversion rate for people who've added an item to their cart. If we were to run this experiment with software in production, it might take several days or even weeks, depending on how much people you have going through that system to collect the data. And even before we can start collecting the data, it might take several days or maybe even a sprint to get the changes implemented. So how can we learn in 24 hours or less? This is the problem we are trying to solve. And I've helped many clients solve this by defining our goal as learning from trying to validate or invalidate an hypothesis instead of learning from running software in production to validate our hypothesis. And this is a crucial difference. The key insight here is that learning from running software is a good method, but it's also the slowest and most expensive way to learn for product teams. There's one thing that I change in the Lean Startup build, measure, learn cycle. And from the perspective of running 24-hour experiments, that change would be, I would always start with the learn as the first step. So Lean Startup defines the cycle as build, measure, learn. I would say learn, build, and measure. So let's take that hypothesis, the hypothesis we just talked about, and define what we need to learn to validate or invalidate that hypothesis. The core question for us, as we start to think about what the experiment is that we could set up, the core question is, would a person that is not shown the shipping costs be more likely to complete the purchase after adding an item to the cart? If we can't answer this positively, then we shouldn't even set up the experiment in the first place. But even if we do answer this question positively, i.e., there would be a higher conversion rate if we don't show the shipping costs, there is a large number of potential answers to that. Because unlike it might seem at first, this question cannot be answered with a yes or no. In fact, if that yes or no would be the only possible set of answers, we would always get either 100% conversion or 0% conversion when we don't show the shipping costs. And of course, it's obvious that's never going to happen. It will never be 0%, i.e. no, and it will never be 100%, i.e. yes. It will be somewhere in the middle, right? Like, maybe there's a 10% higher chance that not showing the shipping costs will convert, as we talked about in the experiment example above. So the question for us is, when we evaluate if we should run the shipping costs experiment as we've defined it previously, we need to prove to ourselves that there is indeed a higher likelihood, and you need to define how much higher, that the shipping costs experiment will yield some value for us, i.e. higher conversion rate. So before we even write one line of code, we need to be reasonably sure we are likely to move the needle, so to speak. Because if we don't believe that, we shouldn't even run the experiment in the first place. Okay, but now this presents an egg and chicken problem. We can't be sure that we move the needle before we run the experiment, and we can't run the experiment before we're reasonably sure. So we need to solve this paradox. Thankfully, we can focus on the learning aspect of the Lean Startup build measure cycle without running any software. We can run a much cheaper and faster experiment and get our confidence up on the results before we actually change the software. So how would we do that? Well, there are several options, but for the sake of this example, we can simply create a paper prototype of the new checkout process and invite 10 people over for a user test. This user test would be different in that we would do a qualitative analysis of the interaction of the users with the paper prototype. For example, carrying out a usability test protocol with those test users. Through this usability test, and by asking debrief questions from the test subjects, we would then be able to increase the confidence on our core hypothesis. Or maybe not, and that would also be a valid insight. In companies like Amazon, there are likely already many usability tests being set up and run every week or even every day. In some of the clients that I've worked with, we've set up the practice of organizing usability tests on a regular cadence, for example, every Wednesday, and then asking the teams to come up with experiments that we could run using that protocol and having the teams themselves observe that test so that they get more insights about the interaction between from the users with the product. The usability test protocol is only one of the many that we can set up and run in 24 hours or less. And here the key insight for us is, and for our product owners, is that if we can learn every 24 hours, we can focus on value and delivering value every single day. And that, in the best case, leads us to tomorrow's episode. Tomorrow we will talk about experiment-driven development, the ultimate goal for Agile teams, which is to learn every day. So today we've covered some key aspects of how to design experiments and then run them in 24 hours or less. Let's review them quickly. First, we must acknowledge that the core aspect of experimentation is learning. And we talked about how the Lean Startup focuses on that learning with the build, measure, learn cycle. Then we talked about how we can design experiments instead of writing only the user stories. And we start by defining what we want to learn, which is the hypothesis we want to validate or invalidate, and then design the experiment, including what we do, what we expect, and the data we will collect. Last, but also very importantly, the concept of the 24 hours experiments is introduced, where we try to maximize the speed of learning because we know that learning is the focus of Agile product development. Now, as I've said before, all of this week's episodes are companion episodes to the Coach Your Product Owner e-course. So let's check out the modules for which this is the companion. This episode is the companion. So in version 2 of the Coach Your Product Owner e-course, Module 8 talks about the critical documents that the product owner is responsible for and should focus on. In that module, we talk about impact mapping, an approach that helps us identify assumptions and expectations that we can later use to define and run experiments. Also in version 2, but Module 9, we talk about collecting feedback faster, and in that module, we discuss how we can collect feedback at different stages of the product development and even the sprint. That module contains quite a few clues on how we can run experiments with our own process of development and learn every sprint. That's another form of experiment-driven development. We can also experiment with our processes. But more on that in tomorrow's episode. Finally, in version 1 of the Coach Your PO e-course, Module 3 talks about what we call actionable metrics. That's also a lean startup concept. And that's a core insight and tool for anyone wanting to run experiments. It's a really important topic and the basis for any successful experiments. Now you can get more information about the course and purchase it at bit.ly/coach-your-PO. That's all one word, all lowercase, bit.ly/coach-your-PO. All one word, all lowercase. Now, if you think that getting coaching and getting hands-on support is a better option for yourself, you can contact us at coaching@oikosofi.com. And we can set up an exploratory call and figure out how you might benefit from this kind of thinking, experiment-driven development. So that's coaching@oikosofi.com. And the link is in the show notes so you can easily find it and email us. Keep learning and keep helping your team. Merry Christmas, and I'll see you tomorrow.
We really hope you liked our show. And if you did, why not rate this podcast on Stitcher or iTunes? Share this podcast and let other Scrum Masters know about this valuable resource for their work. Remember that sharing is caring.